Welcome. Today we're gonna be making a MegaMan X project in Unity. Or this is going to be a series, so today we are going to be working on the first part, the basic player movement. In the end it's gonna look something like this. And this is going to be made in 3D, but you could translate the concepts easily to 2D. So you could use a rigid body 2D instead of a rigid body and replace the 3D models with sprites. The conversion is fairly easily. What matters is the basic concepts here. This is going to be kinda like the final product. Probably not exactly the same, but something like that. So, start by opening your Unity hub. If you have a very old version of Unity, you might want to open the Unity directly, but you will most likely need to open the Unity hub. Make a new project, and first of all, select an editor version. You can select whichever version you want to, but I would recommend using something that has LTS under it. So it is a lifetime support version, kind of a final version for that, for 2020.3. So it's got better support. Then select your templates. You could do a 2D one or a 3D one, or if you really want to, you could choose any of those. But it's best to select an empty one for now. If you're more into graphics, you could use something like the URP or HDRP, Universal Render Pipeline, and High Definition Render Pipeline templates for Unity. But this is something that you will need to know on your own. I'm not gonna go over those, and they are pretty big topics by themselves. It's best if you look it up yourself, or if you already know, you could select one of those. Otherwise, select either 3D core or 2D core. Select the name for your project. MegaMan X YouTube. Select the location. It's fine where it is for me. You could select whatever folder you want your project to be on. Just make sure it's got enough space in it, that it doesn't have more stuff in it. You've got a free location or a location only for projects. And press create. Now this is likely going to take some time, so just wait for Unity to finish, and whenever the project is done, we're gonna continue. Okay, now Unity is open, and we're going to need to do a bit of setup. First of all, when Unity opens, it probably won't look like this for you. This is just my favorite layout, however, a way that I like working with. Yours is likely going to look something more like this. This is perfectly fine too. It doesn't really matter, but I'll just show you the changes I do for my preferable layout. You can choose whatever works best for you. Just moving this and that. And splitting the scene and game windows. Now, you will want to set the aspect to 16:9, or whatever definition you want to use for your game. But a 16:9 is probably gonna be the best for a regular computer game. So there, this is fairly simple. Now, after that, let's create a few basic folders. You can press F2 to rename folders or assets, so go to scenes and add an underscore. Actually, you don't need to do that, but I prefer doing that to make sure that assets that end up in this folder don't get mixed up with the basic folders. So I just add an underscore to the core folders. We're gonna have message underscore script underscore presets underscore refabs. Create a temp folder for any temporary files. and we're gonna make another folder that is not going to have an underscore. Resources. Now, the name of this specific folder needs to be exactly that, but that's not really gonna be of use right now. Probably in future projects or parts of the series. Anyway, we've got that, but we're not done yet. Well, we're basically done, but go to Window and open up the Package Manager. Now go to Packages and Unity Registry, and if you're using Visual Studio, select the Visual Studio Editor and press Install. Now, I've already got it installed, but if you've got that button, go ahead and press it. Now, if you're using Visual Studio Code Editor, you can do the same with Code Editor, if you're using code. Now, if you're using another interface, then there might be a setting there might not be. But this is convenient because it actually shows you the Unity functions and some basic things inside the interface. So you could start typing a name and it's gonna give you the Unity name. So now go to Assets and open C# project. This is also going to take some time, especially if you're using Visual Studio. Never mind, it's actually open. Okay. So let's start by creating a scene first of all. You might see the sample scene be closed, go there and open it up. Right click on the hierarchy and create a cube. Now the cube's position should be on 000, and it should be at the very center of the scene. If it's not, press reset. You can move it around with these parts, rotate it, scale, and do a combination of those. To do that, simply press W, E, R, or T. You could also use those buttons up here. But what I'm gonna do is move it slightly down and expand it, so it's gonna serve as our very first ground. Then go back to the hierarchy window, create a 3D object, the capsule, and that is going to be our player. Now reset the transform again and make sure the player isn't inside the box that we made. Now right click again on the capsule this time and select and press create empty parent. So that's gonna make an object and it's going to be outside of the capsule. You could also do create empty and drag the capsule inside, then reset to make sure it's centered. But if you're using a late version, one of the newest versions, it's gonna have this option. That's convenient. Rename the game object into player X or player or something. Player X. Now go into the script, create a new folder called players. Players. And create a new C# script called player. Double click it. And it should open with your editor. Now erase everything that's inside this block right here. Everything that's inside the class player, erase it, and we're gonna write it again. We're gonna start by setting our own presets. Public virtual void start. Public virtual void update. Public virtual void fixed update. And you might have noticed that we're using almost the same syntax as before, except for this keyword right here, that we're going to use in case future player scripts are going to need to be changed. So if we want to, let's say, make another player and give them some extra functionality at the start method, we would do public override void start and then add whatever stuff we want in there. But for now, that's not important. I'm gonna add virtual to the methods that are going to matter to have a virtual expansion, but some of them are not going to have it. Don't worry about it, you can skip it for now. We're also gonna add some more player-specific methods. Those are all Unity-based. So now public virtual void handle input. Public virtual void move regular. Public virtual void handle animations. We're not gonna do animations yet, but it's nice to have it. So let's make our player move. So in that movement we're going to need a rigid body. So since first of all we're gonna define it. Public rigid body. And because the player is going to require that component, which is another Unity component, I'm gonna go into it in a bit. We're gonna go above the player script and add this require component inside brackets, type of rigid body. Then we're gonna go inside the start method and add get component rigid body. And so now Unity is going to look for the rigid body and assign it in the script, otherwise this would be empty and give us errors. So go back to Unity and wait for it to load. Go to the player X game object, select your script and drag and drop it into the game object. You can do that in the inspector or the hierarchy window, but just do it once. Now go to your rigid body, select constraints and press freeze rotation on all three boxes. So that way the object is not just going to fall randomly. Press play. You can go to the play mode by pressing Ctrl P. And so now you can see the object has gravity. But this gravity is not the strength of gravity we would need for a MegaMan X game. So go to Edit, Project Settings, drag and drop the window wherever you prefer, about it on the project folder. And now find physics, find gravity, and make it 10 times as strong. So instead of 9.81, it's gonna have 98.1. And it's also going to be negative. So keep that in mind. That's normal. Minus 98.1. So now, if we play the game, ignore that for now. We can reset, but that's because the velocity is up. Yeah, never mind. Oh yeah, speaking of that, also go to the rigid body, select if you've lost this menu, press on the player game object again, and select collision detection, continuous, dynamic. Now, we're using that to make sure the player doesn't fall through objects, but for most objects we're not gonna use that exact thing, because that takes up a lot of calculations, a lot of space. So for now that's good enough. Go ahead to your player now, and their forward direction is going to be the direction that the blue arrow points at. That is our z-axis, and that's gonna be where the player is looking towards. So to help us a bit in the future, let's kinda make it stand out. Duplicate the capsule or press Ctrl D, then scale it down. Make sure you remove the capsule collider, because that's going to cause issues in the future. And just duplicate it to give it eyes or something. Now go to project, go to your temp folder and right click, create a material. Give the name like material black, change its color to black, and now you've got a character. Now you've got eyes. And there, that's the start. Okay, we've got our character, the character can move around, but it can't really do much in the terms of moving around and actually being useful. So how do we do that? Let's go over move regular. Now, there are two methods. These two methods are both going to handle input, but they're going to do it differently. Because the way the rigid body moves is handled through fixed updates, while regular input, like button presses, are done through update. We need two different methods, and we're gonna use this to make the player move around left and right, and this to make the player jump. So first of all, vector2 moves input physical get equal to new vector2 input get axis row horizontal input get axis row vertical. Now this is going to use the input method to see if we're pressing the left right arrows and up down arrows, left right for x and up right for y. To get the value, you simply do input.x or input.y. And to change the velocity of the object, we're gonna go body velocity is equal to, actually before that, yeah, no, not yet, I'll go into it in a bit, don't worry about it. Equal to new vector 3, and same way the input is vector 2, so it's got two values, an x and a y. The body velocity is a vector 3 and has an x and y and a z. And that would be input.x times, let's say 10 for now, 0, 0. And so if we go ahead and add that to fixed update, and while we're at it, might as well add handle input to update, then go back to Unity, and whenever it loads, press play, we'll see that the player can move around. Now the player is moving around, but they're also falling slowly. That's because at every frame we take the velocity and set the horizontal velocity to 0. Now change that with body velocity y. So now to change the velocity we only change the x and the z value. For the y value we simply grab the velocity again and give it back to body velocity. So now if we go there, it should work like normal. Yeah, that's normal gravity. And now to make the player jump, we're gonna do the opposite. If input dot get key down key.z, then body velocity is equal to new vector 3, body velocity x, minus 30, body velocity z. Actually that's positive, my bad. And now if we press z, it should make the player jump. There we go. Make sure this is the input get key down is actually in the handle input method, because otherwise it may start eating your inputs. Actually, it almost definitely will, so make sure this is an update and this is in fixed update. Okay, so we have managed to do that, but this is not a great way to handle this type of stuff. First of all, we don't just wanna change the velocity on the x-axis. Well, this is something for a 3D project, but if you want to use a 3D camera, or you want to implement some sort of gravity mechanic, where the player is going to be going around the planet, or anything else really that is going to change the orientation of the character, even a basic gravity gimmick, or a flip, or an input flipped gimmick, you're going to want to actually have a right vector. So let's go ahead and define it. Let's go up under public rigid body, public vector 3 right vec, and public vector3 gravity vec. Now define the right vector as vector3 right and the gravity vector as vector3 down. And actually, to kind of help you differentiate those, go up and add header physics and header world. And now go to move regular and yeah, we're gonna need to split the velocity into the horizontal and vertical velocity. Vector3 well h is equal to vector3 project on plane, body velocity and gravity direction, gravity vec. And vector3 well v is equal to vector3 project body velocity gravity vec. Okay, so now what does vector3.project do and project on plane? Time to explain it with MS Paint, the best tool in the universe. So let's say you've got this vector. This is a 2D vector, it's got an x value and a y value. Now, this vector, if you remember from math class, it can be split into two vectors. This vector and that vector. And let's say vector v would be equal to vector x and vector y. You might remember that from the math class. So v is equal to y plus x. Now we know this vector, we know the x and y, but we don't know the orientation specifically. Like if we wanna get only the y vector, we're going to do 0, y. But we don't know necessarily that this is going to be the gravity vector. If we want to take, let's say, a vector based on that angle, it's gonna be a lot harder to get that vector, to get this thing right there. So this thing could be the project version of that vector. This would be project of v. Project on v on, let's say, a. So now, if you're gonna use a planet, for example, and have the player be anywhere, wherever in the world, you're gonna do this part right here. This is gonna be the center of the planet. This is gonna be the player's position, and this is going to be your upwards vector. So if this is the velocity of your player, for example, you are only going to want to use that one to change their height, to make them jump, and you're going to get that through project. Yeah, okay. That's the idea behind that. But just think of it as splitting the vector into a direction. And project on plane does the opposite. It takes that vector and subtracts it from the overall thing. From the overall vector. So now we've got, let's say, the remaining 3D circle around this. So this would be the center of the circle, and imagine that this is 3D. So vel h and vel v is equal to the body velocity. Well, vel h will be changed to input.x times f times 10f. But we can't do that because input.x is a single float, a single value, and we need a vector. So multiply that with right vec. So now we've got the direction and the magnitude of the vector. and make the velocity be vel h plus vel v. Back to Unity, and let's try it out. I don't think this worked. Oh, never mind, I found the issue. So, you have defined the values right here, but maybe Unity didn't actually see the values. So, if those are set to 0, go ahead and make the right vector to 1, 0, 0, and the gravity vector to 0, minus 1, 0. And now that should work like normal. Yeah, if you use project with a vector 0, yeah, that works like normal. Let's also make the player actually face where they're going, so for that we're gonna go actually under the input but above this whole area. So transform rotation is equal to quaternion dot look rotation right vec times input.x and minus gravity direction. So this is going to change the rotation of the player using quaternions, which is a Unity method. You're gonna get the hang of it. Just keep in mind that look rotation requires a forward and an up, although you could skip the up vector, but that's not recommended. Then for the right vector, you're using the input, the right vector and the input, and for up is the opposite of the gravity direction. But we only need that to happen if there is an input, otherwise it's gonna give us a 0 on the forward, and that's not good for quaternions. So if input.x is not equal to 0, then change the rotation. As you can see, the player now rotates like normal. So that works pretty well. Okay, this is like 20-25 minutes into the tutorial, and we aren't really anywhere close to done. So this might have to be split into a two-parter, into two parts, but I'm not sure yet. For now, let's go ahead and change the stage a bit to be a bit more useful for our transformation method. Well, to be a bit more transformed for our MegaMan X project. Okay, so go ahead, move those around. Try to not have the scale be negative by dragging that way, although I don't think that really matters actually. I'm just gonna try to make a tall wall, then platform up here, well, a wall up there, or like not another right here, and the tall platform to be as our target. Alright, there's also this, I suppose that might be useful. That's the Y button, also useful. And finally small area like that. Tonight kinda looks like the other one. Like, that kinda looks like our sample project, but it doesn't have to be the same. And the slopes, ignore them for now. Okay, so you can move around, but if you go up against the wall, you might notice this problem. That is because by default Unity gives friction to your game objects, to your rigid bodies specifically. So go to presets and create physics material, name it frictionless, change the dynamic and static friction to 0, and then go to the project settings, physics, and attach your frictionless material to the default material. That should fix the issue, there we go. Okay, so we added the input, the very basic input, but unfortunately that class, even though it's very simple to use, it's pretty outdated. Unity has started using a new input method for quite a while by this point. So we're gonna need to change that. Now that you got the basic concepts, we can do that. So go to the package manager and find input system. Press install and wait for it to install. Now this might take a while, but when it does, you're gonna notice because it's gonna show you a pop-up. So let's wait for it. When it is ready, it is going to show you this warning message. This means that the old input method is no longer going to work and you're gonna have a new system instead. This is also going to give you a few errors here most likely, but don't worry about those yet. This is also going to restart your window, that's also perfectly fine. Just wait for Unity to start up again, and it should all be done by automatically. Well, we're going to need to change the input, but that's gonna be easy. Okay, your Unity should be back open again. If you're getting this pop-up all the time, feel free to untick this. And you don't need to update at every version. It's best if you find one good version and stick by it, or update very rarely. Like, if you constantly update your project, it could give you weird bugs, so find a lifetime version, on version with lifetime support and stick by it, or update it to the next one whenever that's out. You don't need to experiment too much with your main project. Okay, so that aside, go back to the presets and create a new input actions thingy. Call it player input. Select generate C# class and press apply. That's gonna make Visual Studio pop up, but that doesn't matter. Now press on edit asset, and that's gonna show you a window. Just throw it wherever you prefer. I prefer putting it there, with the scene window. Go to action maps and create a new action map. Call it player. Then delete the default action and create a new action called movement. And that's pretty much going to be your up, down, left, right. So change the action type to value and the control type to vector2. Then delete that binding that it gives you by default and press up, down, left, right composite. This is going to be the inputs for the keyboard. You can add as many of these composites as you want, the bindings, and you can have them be whatever platform you want them to be. Now for now, I'm just going to use the simple arrow keys. That's not the up arrow key. Up arrow, down arrow, left arrow, and right arrow. You could also do the same with the controller. Press the same thing again, add another composite, controller, and go to gamepad, select the which one again? I kind of forget. This is the left stick, right? Or... yeah, it should be. So select left stick up and then down, same thing. Stick down, left stick left stick right. And congratulations, now you also have controller support. Also, this asset you need to save, so feel free to press the save asset button or press the autosave on. Although autosave makes it kinda slow, so I prefer using the save asset button frequently. But if you forget a lot, feel free to just select this and it's gonna save things automatically. We're also going to make buttons for jumping and dashing. So call this jump, and this one needs to be a button, so you don't need to change anything. Remove the original and create a new binding. Well, you didn't need to remove the original. I'm gonna assign it to Z, but you can use whatever you want. Same for dash. I guess you don't have to delete it. And I'm gonna use X. Save the asset. Okay, now go back to your Visual Studio project. And I guess it hasn't updated yet to show the errors. Let's see. Go to the very top of the class, the header input, and that public player input control. And this is going to be what's going to give you all the inputs that we just made. So make protected virtual void on enable and protected virtual void on disable. We're not gonna use that one yet. But on enable, input control is equal to new player input and input control dot player dot enable. So now your player game object is going to be listening for inputs. This method, it's not going to be used inside the move regular thing. Instead, we will be assigning it outside and grab it inside the method. Grab it through the method. So public vector2 input is going to be a variable here. A public variable. Now, to actually change the input, you need to do input control dot player dot movement dot performed classical ctx this symbol and that. So it's a bit complicated, but you can get used to it pretty easily. So this is gonna give you this box in here to write, and it's kinda like a method. So go inside there and add input. The input is equal to the ctx read value vector2. So this is a bit complicated compared to previously, but it's going to help you out a lot in the long run. This is a much better input version than the default Unity one, and I don't believe the previous one actually lets you change the buttons and the controls in game, and this one does. And it's got a few more weird things, like with a few controller buttons. It's just weird, so this is worth the investment. So copy the same thing, change performed to cancelled, and set that to vector2.0. So that way, once you stop pressing buttons, it's gonna go back to 0. Now to check if the jump button is pressed, we're actually gonna only check if it is held down or not for now. So public bool pressed jump is equal to false. You don't really need to set that. And we're gonna do the same, public control, player, movement, performed, classicals, ctx, this symbol, and you don't need to expand this. Oh wait, classical. Yeah, and here press the jump is equal to true. Same for cancelled, and change it to false. Don't worry, later on we're going to improve this. It's gonna be its own class later on. But for now we're just gonna have to do this, same for das. So, actually hold on. My mistake, change movement to jump. And here I changed it to das. With Ctrl and Shift, and then Shift and Alt, you can select multiple lines and write them all at once. Create another variable for das. But that hasn't fixed all the errors yet. Change that to press the jump and try to Unity. If you didn't remove all input dot from the previous input, it's going to give you errors. But now we should be fine. Yeah, it works, but it works, you can press it as many times as you want, and while you've got it held, it keeps pressing. So that's multiple errors. First of all, we need to check for the ground to see if the player is actually standing on something. So we're gonna get the shape of the player, the capsule, and do some physics to check if there is ground underneath. So first of all, we're going to need the size of the player. Public float height is equal to 1 and public float radius is equal to 0.5. Now these values work with the default stats for the player there. Like, if you go there, expand this and see the capsule, those are gonna be half of the height and the same radius. And the object isn't the center, so that's why we need half the height. And wait, there's an error. Oh no, never mind, that's fixed. I just didn't save. But you're likely not going to be sure that you've got the right values. So add another Unity method, public virtual void on true gizmos selected. Gizmos.throw wire sphere transform position minus transform up times height and radius. And also change the color with gizmos color is equal to color dot select your color, blue. You can also use custom colors by doing new color and using RGB but from 0 to 1 or RGBA. So now once we get here, that should give us a small sphere. If we're selecting the player, a sphere that's at the very top of the player, like at the player's feet right there. You can change the values, the height to move the sphere up and down, and the radius to change the size of the sphere. But this is going to be a good default. If you change the size of the capsule, make sure to change those also. And make sure that the eyes don't have a collider. Again, a reminder, because that can also interfere with a lot of things. Okay, so let's go to the very bottom of the script. Or at least that's where I like to put those methods. And we're going to make a method that uses physics and checks if the player is on the ground. So public bool is grounded. Float add distance is equal to 0f. So you can see how far down you're gonna check, but normally you don't need to include that variable. Only make it 0.1 for convenience. And we're going to use something that's called array cast. So let me explain that first. You get your normal capsule right there. You've got your center, and you wanna check down. What you're going to do is use a line and use physics to see if there is another object in that line. So if there is an object, it's gonna give you that spot. We're also gonna change that slightly in the future, but for now we're just going to do arraycast. Return physics.arraycast transform position my gravity back, yeah. And if you see this and press up and down, you're gonna see all the variables. So we're going to use an alright, actually we're gonna need a heat to arraycast heat to return the results, but those are not going to be useful yet. Just add this for now, hit ground, and add out hit ground. So that's going to return the point that we got and the direction of the ground. But we're gonna use that later on. Also, the distance is going to be add distance plus height and 8. So let's start by explaining that last variable. Now, if you're using a collider, you don't want to check every single object. You don't want to check for the player's collision, you don't want to see the enemies, you just want very specific objects. So, these things. To separate those from everything else, we're going to use the layers. So, go to the game object, select add layer, make one, and call it solid. Now, I'm using slot 8 out of habit. You can select whatever you want, but you need to make sure that this is actually set to the same slot as your layer. And also, because this is going to be very messy, make sure you select all the objects in your terrain and create a new empty parent. Call it terrain. So now, if you move this, it's gonna move everything. And you might wanna center it, you might not. If you wanna do that, make sure you put everything outside of it, reset the coordinates, and select all the objects, put them back again. Now change the layer of the parent object and select yes, change children. So that's going to change the parent object and all the other objects inside it. And then the new objects you make should also be of the same layer. So yeah, now all of these are considered solid, but another object the player is not going to recognize as solid. Okay, that's all and good. But we actually need to use the isGrounded method to check if there is ground under the player. So go to handle input, put the velocity in parentheses, because we might need more stuff than just the jump. If grounded 0.1 f, or you can skip that entirely for now, since this is just going to check a small distance under the player. And if you put that check up, it should make sure that the player is on the ground. Yeah, so now no matter how much I hold down the key, the player only jumps when they are on the ground. And yes, that happens while holding down the key. We're going to implement a key state check in a bit, but actually hold on. Is there anything before that? Oh yeah. But we're not done with the isGrounded method yet. First of all, take the layer mask and make it an integer. Solid layer is equal to this. And add solid layer there. And so that way, in the future, we could move this outside of this method and add more layers. Like if we want to make another layer, let's say layer 13 also be solid, we can do this. But that's not important for now. For now, just move it outside and like that. A more significant problem we have right now is that we've got the player right here, and let's say they do the raycast down there, and there is ground here. That's nice, all good. But what if they're on the edge of the corner of an object? Like that. This is going to count as no object underneath, but this area right here is supposed to use to actually touch the ground. So, or if you've got a slope, like this part might be touching a slope, but this might not be, and there's all sort of weirdness. So raycast is not optimal. What we need right here is a capsule cast. And the capsule cast is going to take 2 points, which would be the points where the origins of the circles inside the capsule that you've got. So think of the tips minus the radius, that's not that important. It's going to take 2 shapes, make a capsule out of them, and move that capsule in this direction. So it would move this and this, make this, and it would do a check all along this way. So we're gonna replace this with a new method. Basics.capsulecast. Oh, but hold on, okay. I'm jumping ahead. We're not gonna need that yet, so we're only going to need the down circle. So we're going to do a sphere cast. So just using one sphere like that. It's gonna set all along the way. Yeah, sorry, I'm jumping a bit ahead. We'll get to that when we get to it. So sphere cast, transform position. Now this needs a radius. So do radius times 0.9f. We're making the radius a bit smaller so it doesn't check walls and register those. Give it a bit of error. Gravity back again. Out, hit ground. And we're gonna do height plus add distance minus radius in this. Because the radius is also included already. And again, solid layer. And this should not make any difference in the game, but it matters a bunch later on. But yeah, this should also work like normal. So let's get to the input, and I think I'm gonna get that video in here actually. How long has it been? It's not almost an hour, so yeah, I think we're gonna make the input and cut the video here. And after that we're gonna do things like hole sliding, dashing, and actually no, let's do the input, then we're gonna handle slopes, and after that everything else. So yeah, let's make the input first. Right click inside the player script folder, right click, wrap script, and input control. Yeah. So it's the same name as the input control from before, but we're gonna change how it works. Go to the very top, grab all of those and control X. So use the cut method. Instead use public player input, no wait, input control, same. Remove the mono behavior part because this is not going to be a Unity object. This is going to be a basic C# class. And go here, copy all these, remove that, and we're going to use the same names on enable and on disable, but these are not Unity methods. Although I guess that wouldn't really matter if you are just learning. So copy paste these things, and they should practically have the same functionality, except instead of just having press jump, go input control, press jump, and input control.input.x to get your methods. There should be 3 instances, I guess, of input control and one of press jump, and make sure your game runs. Make sure that, yeah, that you've added all the things. But this is actually not going to work. Never mind. I forgot one thing. Go on enable inside the player inside the player script, and input control is equal to new player input. And input control dot on enable. Okay. This needs to be public. My mistake. Don't worry, there's going to be a lot more mistakes like that. But yeah, go there, add the onEnable on the onEnable method, and onDisable on onDisable. And now that should run like normal. If those errors bother you, don't worry. They are just going to disappear when we press play again. But you could also press clear. And that works like normal. And yeah, but the keys actually have they've got a bit more than just if it's pressed or not. We're going to check if the key has just been pressed or released, if it's held down, or if it's not pressed at all. So for that, we're gonna make a public enum key state. None press hold release. So if the key is not pressed down, it's gonna send none. If it was just pressed on that frame, it's gonna be pressed on hold if it's been held down for more than a frame, and release if it was just released on this very frame. So I'm gonna move this down a bit. I hope I didn't hit the mic. And above pressed jump and pressed dash, we're gonna make public key state and key jump. Same for the dash. We're going to make a few methods now. Public void update input states. Then public ball is held to check if an individual key state is held or if it's on press or hold, since in some cases that's actually going to be useful. Turn state is equal to press or state is equals to key state hold. So I got key state, update key state, and that's going to be the important function for this. This is going to get your key state and whether the key is pressed or not, just if it's held down or not, with this, which we're using the player input for. That only has a yes or no, and we're going to update the key states. Key state, start state, ball pressed. Is there an error? Nope. Yeah, so if pressed, then if the card state is equal to key state.none, card state changes it to key state press, else if card state is equal to key state.press, card state is equal to key state.hold, else if card state is equal to key state.release, card state is equal to key state.press, and I suppose else. Well, we're gonna do an else if just to have it so better, but not really gonna matter. Else if card state is equal to hold, just have everything. Card state is equal to hold. Else on, oops, yeah. Double equals for checks and single ones for assignments. So doubles in the ifs, singles in the sets. And we're gonna do the same. First, yeah, the same. If car state is equal to hold, car state is equal to state release, else if car state equal to release, car state is equal to none, else if car state is equal to press, car state is equal to release, else if car state is equal to none, car state is equal to none, and return the car state. You're going to find those all in a GitHub project, so don't worry about it. You can find all the code in the project entirely. So don't worry about that yet. These are just basic things that we need. It's very specific but very simple. So verify from none to press, press to hold, release to press, and hold to hold. Hold to release to none, press to release, and none to none, yeah. So now we're gonna use this method for our jump and our dash buttons. So we're gonna use key jump is equal to update key state, key jump pressed jump. And it does, pressed it does. Also, go ahead and change those to private, so we don't access them from other scripts. We don't really need to, and that's going to give us an error that we're going to use jump is equal to press. I saved, nice. And now that should mean that the player would only jump on the first hold on. Okay, we're never really done with this. Go to the update method on your player, input control, and change is change and that update input states. Okay, so now as we press the key button, it should only make the player jump once. So whenever it loads, I'm gonna hold down the jump button. It only happens once. Press it again, hold it, and yeah, it only happens to the frame that you press it. So far so good. Yeah, we've got a pretty basic player script, and it works pretty well. But as soon as we introduce slopes, things go sideways. Really. I'm just gonna change this to minus 45 degrees for now, and move it so we've got a pretty large slope right here. Okay, so we go up and the player goes down. We jump, they fall down, and they drop down. That's not how an X game works, and that would keep happening no matter the slope, by the way. If we try out a smaller slope, it's gonna be the same thing. So for that, we're going to handle how Unity does the gravity and the drag, but we're gonna do it ourselves. So go under this, actually go above handle input, or wherever you prefer. I prefer this direction. Public, void. This probably won't need to be a virtual. Void. Apply physics. If not, it's grounded. 0.1, we don't need it. Then body.velocity, classicals, and we can use classicals here. Gravity vec times minus physics dot gravity dot y. So that's going to use the gravity vector, and because remember the gravity setting on physics is actually negative, we're going to use the opposite one. So the the positive value pretty much. We could also use an absolute value. But yeah, that works, but we haven't actually applied it. So go to fixed update at the very top of the fixed update, and inside those methods it actually matters what order you put things in. So at the very top, just put apply physics. Then go to start, body.use gravity is equal to false, and body.drag is equal to 0. That we're gonna do in a bit. So now, if you go up the slope, it should be fine. Actually, it's not. Hold on, I did something wrong. Because of physics, you also need to add a delta. So you would be adding this type of gravity at every single frame, but instead we're gonna add it per second. So we're gonna increase by that value in 1 second. So simply multiply it with time.fixed delta time. And everything that is physics based and is inside the fixed update is going to use fixed delta time, If you're using input, it's going to need time delta time. Don't worry about that for now, but it's going to come in handy later on things like timers, for example. So we're gonna make use of that later on. For now, just ignore, but just multiply the per second by delta to get the individual frame value. And that should work. Hopefully. Hopefully. You never know, but yeah, that works. And the slopes are also fine. Now we've got this little issue right here. So let's fix that real quick. We're going to make another variable, one that checks if the previous frame was the player on the ground. And protected ball was grounded is equal to true. And so we're gonna go to apply physics, and was grounded equals is grounded. Actually, since this is using physics, we're gonna make a variable whose ball is grounded. Yeah, okay, I messed that up. It's called is grounded. And to kind of differentiate it, just call it on ground, I guess. Call on ground, and if on ground, and was grounded equals to on ground. And we're also going to add a state for if the player was not on the ground and they are now, they're going to remove the vertical velocity. Remove that sliding down. So if not was grounded and on ground, then the velocity is equal to vector3 dot project on plane dot velocity gravity direction. Or just to keep it consistent, we're gonna do vector3 val age is equal to this is equal to val age. And that should significantly reduce that type of impact. Oops, press the play twice. Oh wait, I guess I messed it up. Oh wait, okay, yeah. So I just messed this up. If the player is not on the ground, then apply the gravity. I just removed the minus there. Gravity doesn't apply. Needed to. So it would only apply gravity if we were on the ground. So like the slope. Yeah, that works like normal. And this has minimal impact. So it works pretty well. Almost. Okay, so we don't slide down the slopes, but we also don't move gracefully down them. So what we're gonna do there, actually I'm gonna show that in MS Paint. And as the player moves down the slope, actually I'm gonna make the player the same color as the slope since they're not the important thing here. As the player moves down the slope, they move on the right vector. And in this case input is -1, so they move left. So they move that way. So that's going to make the player generally move that way. And they're gonna go mid-air. Then gravity is going to start dragging them down and down and down. And when they hit this spot, they're not gonna have any gravity. Then they'll move that way again. And down and down and down. And that's why the player hops right there. So what we're gonna do is actually get the normal of the ground. So let's say the player does the raycast that, or the spherecast that we did before. They check down, they see this value, and we want to get this vector. This would be the normal of the ground. That would be at 90 degrees with the hit point, with the point that we hit. Thankfully, this is what hit ground is already for. We're just gonna move it outside the is grounded value, make that protected, And that's a build that we need for this. Now we're gonna call this the move vector. So go above the rotation, since we're not, go under the rotation, ignore that for now. Vector 3 move back is equal to right back. So we're going to replace this with that. And now what we're gonna do is actually rotate the vector, the move vector, and this would be our normal. Now we want to get this vector pretty much. So we're gonna rotate the normal by 90 degrees, first of all. But that's gonna cause a few more problems. Now, only if it's grounded. Grounded only then change that, and we're gonna use 0.3 to get a better check, a more thorough check. To do that, we're gonna do move vec, the vector is equal to quaternion.angle axis. So that's going to rotate our vector by a set value in degrees in a specific direction. 90f transform right. And since the player actually rotates, it's going to rotate the normal at the right direction. And skip dot normal. This is a rotation times a vector, and this rotates the vector in Unity. But this is not going to be enough, because, well, it depends on your project. Now, if we do that, you're going to notice a pretty big problem, or a pretty big difference. Normally, the player would move at, let's say, this direction, now they're gonna move at that direction. And this is not the same horizontal displacement as the other one. So we're gonna need to multiply the entire vector to make sure that the horizontal value reaches this value, pretty much. Now to do that is fairly easy. We're going to do float dot is equal to vector 3 dot right there, move back. There we go. Direction, not dirt. Actually, hold on. Alright, yeah, I'm using the cheat sheet and the values are different, so my bad. But yeah. This is the dot value. This is pretty much this vector right there. Or actually the size of that vector. So if let's say that was 1 and that was 1, this would have been 0.5. So we're going to divide this vector with that to get this. If dot is not equal to 0, so I don't divide it with the 0 because that's a whole different problem. Move vec is equal to move vec by dot. And this is also going to solve another problem. The way we did our rotation, we could actually get this vector or this vector, and we only want this vector. Even though I've been saying this is the vector that we want. The vector that points at the same direction as this, the original vector. So since this is actually going to be minus 0.5 and it compares to this vector, yeah, don't worry if it's a lot of math concepts, so don't worry if you didn't catch it, it doesn't really matter. So it's also going to change the direction of the vector to make sure it goes the same way as the right one. So now, if everything worked well, it didn't. Oh wait, right. Yeah, no, so one thing, we're still not quite done with this, because right now we're actually adding that vector entirely to the velocity, so we're pretty much making the player jump. But instead we're gonna use another Unity thing, Again, don't worry if you don't get that, it's pretty technical stuff. So we're gonna make another vector, vector 3, well, 8 frame this. So it's gonna be the displacement on this individual frame. Hold on, I'm gonna grab my tits and it's equal to vector3.project body well aids on gravity back, and it's the same thing as before pretty much. And well aids under that specifically is equal to vector3 project on plane well aids on gravity back. So now this would work like normal, and we're going to individually move the position of the player afterwards. Body position plus equals well aids frame displacement times time fixed delta time. Since this would be the movement over 1 second and this is the movement over 1 frame, so include the delta again. And this should work, hopefully. Only one way to find out. That doesn't work. Oh no, wait, put that above. You know, this is the final value, not just the direction. So these things that we did need to be under this. You know, hold on, I'm dumb. You know, make it move back again, and do keep the chains, put them above everything else. Okay, kinda messy, but that's fine. I mean, again, you can find the code on GitHub, so that should be fine, and now it works perfectly. You've got great movement up and down the slope, and you've got the landing, the everything. There we go. Another thing, so far we haven't really made any changes to the plane that the player moves. We haven't put them down on that plane, so they might potentially slip to the z-axis. So to prevent that, for now, do a freeze position z, and that's gonna be fine. We're probably not gonna touch that for a while, but this should ensure that this value stays 0, or at least on its own. Also, a small change that I just realized on the game, change that to go to handle input and under the jump, make this a 0.3, so that we give the player a bit of leeway in the jump input. Okay, so this is it for now for this tutorial, I believe. I don't think there's anything else I'm forgetting. Next time we are going to do wall slides and wall jumps, and we're gonna probably add some more things. I'm not sure what yet. I'm also not sure if the values are actually correct. Okay, that's not right. No, it's not right. That's not supposed to be like that. Does the player keep saying? Okay, actually we're not done. And I remembered another thing, so yeah, no, give me a minute. Okay, so we're not entirely done yet. Let's go over to apply physics. Nope. Okay, yeah, apply physics. Change that to 0.2, let's say 0.2f. And hopefully that works. Hopefully that fixes it. And it actually does. Or does it? That seems fine. Then okay. And another thing. Let's actually make variables specifically for the movement speed and the jump force. So header layer dot public float move speed is equal to 10f and public float jump force is equal to 30f. And these values are not precise. I'm not sure that these are correct, so you can play around with them. See what's more MegaMan X like. And the same applies for the gravity, by the way. This feels good enough, but I'm not entirely sure that this is correct, so you could also change this value. But keep in mind that to make the player fall faster, you need to change the gravity and the jump. So increase gravity, increase the jump. And that's the only thing really. Then change on handle input jump, this with jump force, and then move speed of regular, the 10 with move speed. And that shouldn't really be a major change, but it's going to be just more modifiable. You can mess around with those and set them whatever way you want to. So if we increase that, that happens. And the player is gone. They keep going up and up and up. You know, that would probably break your game. But we're back. And you know, so that kind of froze things, so don't do that, it kinda broke everything. But yeah, just, you know, play it like normal and it should be fine. Yeah, this would be all for now. Thank you for following along. I hope I didn't get too annoying with all the corrections, but they have to be done. Hopefully by this point you've got a fairly precise platformer. Next time we're going to make the dash and the whole slide, and I'm not sure, I feel like they are not going to need as much time as this. I mean, this is over an hour. So next time we're going to do the more MegaMan X style stuff. Maybe include a double jump, an air dash, yeah, define how many air dashes you can do, and maybe hover. Yeah, hover could also be nice. So maybe that's the goal for now. So yeah, I guess that's it. The usual YouTube stuff. Twitter, other links you can find in the description. Twitter, Discord. I'm working on another project. Also some art. You know, the usual. If you wanna check it out, do. Otherwise, don't worry. It's all good, and I don't know when the next tutorial is gonna come out, but hopefully soon, and see you later.